A pleasure to be with all of you this afternoon. At least it's afternoon in Chapel Hill, North Carolina here, but wherever you are, welcome to our webinar about finding money in the water system budget, how to pay for energy improvements. This is a part of a project by the Environmental Finance Center Network, a network of environmental finance centers around the country like ours here at the University of North Carolina, and Laura's there at Syracuse University. Our project is the Smart Management for Small Water Systems project. We've been working on a nationwide basis to help small drinking water systems serving 10,000 or fewer people in all the states and territories with their financial management, energy management, asset management, water loss reduction, and many other things. We do offer, in addition to webinars, we offer workshops, e-learning modules, different online tools, and direct free technical assistance, which if any of you are interested in for your small water system, we'll be launching a polling question at the end of the webinar to get you plugged in for that. Here are the environmental finance centers that are part of the network, including our two. And I was telling you about different areas of the project. You can see on your screen now for today's webinar, it is energy use and efficiency, or energy management, one of the largest controllable costs on the variable cost side for your typical small water system. Here at the University of North Carolina's EFC, our team is dedicated to enhancing the ability of governments and other organizations to provide environmental programs and services in fair, effective, and financially sustainable ways. As we like to say, how you pay for it matters. This is the fourth in a series of energy management webinars. If you missed any of the first three, you can go to our project page. You can see the URL at the bottom of your slide at efcnetwork.org, and we have the slides and the video recording archived there. The slides and the video recording from today's webinar will be posted there within a few days after the end of this webinar. We have some wonderful expert guest speakers today, in addition to my good colleague Glenn Barnes here in Chapel Hill, who will be helping me out today. We have Mr. Corey Cox, the Public Utilities Director at the City of Pickens, South Carolina, which is a small drinking water system, and Mr. Frank Shepard, formerly of Siemens, an energy services company, and who now works as a consultant both with the Schultz Engineering Group and with Ally Engineering. In just a few minutes, I'll be giving a brief overview of how to pay for it, with a special focus today, a bit more of a deep dive today, on one method called energy savings performance contracting, or just performance contracting for short. To be sure, that goes beyond how to pay for it. It also, as you'll see, is about other services. But for those of you who are small systems, don't tune out now, because you're going to see in a minute there are a lot of small systems around the country that are in fact doing this model, and that's part of what we want to bring across today. Then Mr. Frank Shepard will talk about his perspective from the energy service company side. Mr. Corey Cox will talk about his perspective from a local government owned and operated small drinking water system there in Pickens. Go ahead and type into the chat box, like Laura was mentioning, your questions at any time, and in the last 10 minutes of the broadcast we'll get to your questions on air. If we run out of time on any of them, we'll get back to you off air as soon as we can after the webinar is over. Laura's going to launch a polling question for us right now. You should see on your screen. Please choose one answer to the question of what kind of drinking water utility do you represent. Granted, some of you may be consultants or state or federal officials, so we've got that last answer there for you if you are not a drinking water utility. And this will help us know more who's here on the line with us right now, which is helpful to me to know in talking to you guys today. All right, well, Laura, if you wouldn't mind launching the answer to that polling question so people can see it on air. And as you can see, about a third of y'all are drinking water systems of one kind or another. And then a little under 2/3 of you are not drinking water systems, but hopefully a good deal of y'all work with the systems. Let's move to the second polling question. For those of you who are systems, we're curious to know what size you are. So Laura's going to launch that right now. Want to see if you're very small, small, medium, or large systems. And while that is being launched, I'll point out that while the Smart Management for Small Water Systems project is primarily designed to help those of you who are small drinking water systems serving 10,000 or fewer people, any size system, or folks who are not systems but work with them, welcome to go to our website and use the materials that are posted there. All right, so I think Laura's going to show the results now, and it looks like for those of you who are systems, we've got 15% that are large and about 23% that are small or very small. All right, and we got one more quick polling question for you now before we move on to the first presentation. So for those of you who have dealt with energy savings performance contracting before, we're curious to know, in fact, if you have never heard of it, if you've heard of it but haven't tried it, if you're currently doing one, if you've already finished one, or of course if you're not a drinking water utility, that wouldn't apply exactly. All right, well, we're seeing the answers roll in now. And Laura, why don't we go ahead and launch the results there. All right, well, in a sense, this is good news because it means that we definitely have something new to share with y'all who have not heard of it or not done it yet. I see there's got to be at least one system there who has done one, and I'll just invite that system that if you're interested, you could type something in about it as a comment to your chat box, and when we get to the Q&A session, we might even want to share some of that on air at the end of the hour. All right, well, enough polling questions for now. I'm going to try and give y'all a sort of 30,000-foot overview of how to pay for it with a focus on performance contracting. So broadly speaking, how do you pay for your energy management projects at your utility, at your system? You can pay as you go out of current receipts. You can save in advance and pay out of your fund balance or your capital reserve fund if you've set up a separate capital reserve fund for your system. You can pay later, meaning somebody's loaning you money now and then you've got to pay them back. Or if you're lucky, you can get a grant. Though those are not as plentiful as we might like them to be, and you're letting someone else pay. I don't say that that's free money because someone is paying there somewhere, and it's oftentimes the taxpayer. What is the best way to pay? Well, the answer to that is probably it depends. So if you want to pay as you go, that can be a best option for a small improvement. After all, if you're doing something like, say, switching out all the exit signs in your facility to LED lights, and you're not spending millions of dollars or anywhere close to it, just paying out of cash and not having to deal with the paperwork, the administrative overhead of other ways of financing things can be a good way to go. But as we all know, for capital projects, we can't always pay out of the pay-as-you-go approach. So these others, fund balance, pay later grants, they may be best for the larger energy improvements. But again, it's going to depend on your particular situation and your philosophy of how to finance your projects. One thing we want to make sure that you are aware of, and I'll have other links at the end of the presentation that also can be useful to look at, but our colleagues down the road at North Carolina State University, they maintain the DESIRE database, the database of state incentives for renewables and energy efficiency. And you can click on each state or territory when you go there. You can see part of the map there. And it will tell you about relevant legislation and regulation, the existence of current financial incentives or special energy funding mechanisms. And that is a useful resource to consult, especially because in the case of energy savings performance contracting, there are differences in regulation among different states around the country. So what is an energy upgrade? An energy upgrade to your water or your wastewater system, because we know some of y'all have both, is really just a capital improvement. So you're going to be able to treat an energy upgrade like any other capital improvement with respect to things like going to your bank and applying for a loan or spending out of your savings there at your system. We'll say more on that in a moment. Some principal areas that capital funding can come from. Well, if you are a utility that charges rates to your customers, which we understand that some of you who are on maybe water systems that don't do that. You may be a hotel or a school or a condo complex. You can get your funding out of revenues generated by your rates, your monthly bills. Also, assuming you're an entity that has the authorization to do this, special assessments to current customers, or one-time fees such as impact fees to new customers. In theory, all of you could go in one fashion or other to the debt market. Some of you, such as those who are community water systems, may be eligible to apply for funding from your appropriate state or territory agency from the state revolving funds. You can look for grants. And there may be other ways that your system generates revenue to do an energy management project. An energy upgrade is also not just a general capital improvement, but it's a special capital improvement. Because it's focused on energy, there are other kinds of special funding options available. There's several we are not going to get into today, but we're glad to talk to you about off-air if you're interested. Things like setting up an internal energy revolving fund, or if your project is, say, you've put some solar panels on the property there and they're generating energy, a power purchase agreement may be relevant. But what we're going to focus on today with a little more of a deep dive is performance contracting. So a few words about performance contracting before I turn it over to Frank Shepard. This map, we wanted you to have a quick look at just here in the southeastern U.S. We talked to some friends of ours, and without even trying very hard, we were able to find quite a few examples of projects for actual small systems serving 10,000 or fewer people, or some not quite small systems, more like in the 10 to 15 to 20,000 range. And we just teased out several of these here. Pickens, South Carolina, where you're going to hear from Corey in a little while about their experience. Bremen, Georgia, and Gulf Breeze, Florida, all have been doing energy projects using this method, both for advising and structuring and consulting on the project, as well as how to fund it. So with performance contracting, an energy services company, or ESCO, works with you, your system, to propose and design a package of cost reduction measures, install and implement those measures with you, and then to guarantee the savings of the cost reductions. As such, and this is a bit of a simplification here, the ESCO may put up some or all of the capital for the projects. In reality, there's probably going to be a separate financing contract through a separate financing firm or a bank, but this will vary exactly how this arrangement is made given what state you're in and what ESCO you're working with. The ESCO will, generally speaking, pay itself back for the package of energy conservation measures over time using the stream of revenue provided by the energy reduction measures themselves. There will also typically be a third party involved, a measurement and verification, or M&V firm, that does that work and provides a reconciliation report both to your system and to the ESCO. Now, we do know of at least one case where the ESCO themselves did the M&V work, but from what we see, it's typically a third party. Why not do the measure yourself or the measures yourself without involving an ESCO? Well, you know, you can do that if you have the time and the bandwidth, but an ESCO that really is good at what they do, and there's a lot of them out there, there's advantages. They bring capital or access to capital. They bring expertise. They bring manpower. And they bring this really wonderful part of guaranteeing to you the savings the way you set it up in the package of measures and the contracts for those measures. More advantages of performance contracting It's a process with a single point of responsibility for the work itself. You know, the ESCO might subcontract to people, but from your standpoint, you're just dealing with them. Access to capital, like we said, engineering and project management expertise, and again, the guaranteed performance and savings. A successful project will assemble stakeholders. They're going to create a data packet with you. It's a very typical thing that your system will issue an RFP, and you'll take proposals from different ESCOs, and you'll pick the one that's the best candidate for you when you select them. You'll want not just a sort of run-in-the-mill energy audit, but you'll want an investment-grade audit to get a really good handle on exactly where you're starting from, your baseline, and what your opportunities are for progress. You'll negotiate the contracts with the ESCO, a financial contract in many cases, and oftentimes there's a separate measurement and verification contract too. If you're a government agency, you may have to get approval from the relevant part of your level of government for doing this. The measurement and verification part, I'm going to skip past this. You know, I think we kind of talked about that already. This is a graphical representation here of how, with the costs and the savings, how it all comes together. And again, to stay on time here, let me skip ahead to this one right here. On the left, we've got the situation before working with the ESCO, your total operations budgets or utility bills. In the middle, this is a representation of what's happening while the project is underway. Up top, those are the guaranteed savings, but part of it is going to, you know, the cost of finance, the debt service. Part of it's going to the M&V firm, and then that yellow part, that's the gravy you're getting right now. That's the savings that are coming to your system during the project. After the project is over, typically you're going to own all of the improvements that have been made. That yellow part you see gets bigger on the right. You get all of the cost savings or all of the gravy there. This is a brief comparison of different pieces of the process regarding planning, bids, speccing out the projects. It's a good slide to refer back to, but again, we're focusing more on the financing piece here, even though an ESCO does bring a lot of other things to the table besides access to capital. And now I want to switch it over to our friend Mr. Frank Shepard. Quickly, I'll introduce him and then let him run with his presentation. Mr. Shepard is a senior mechanical engineer and account management leader with over 30 years of comprehensive experience in successful work on different kinds of energy efficiency solutions, including HVAC, work with the water system, pumps and motors and things like that. He's worked before with Trane and with Siemens, and now he is a consultant, hung out his own shingle, but also working with a couple of other firms. One of his projects in the past was with the city of Kings Mountain here in North Carolina. So Frank, please take it away.
Thank you very much, David, and I certainly recognize some of the slides you had there a while ago. They're very excellent, and you did a great job of preparing the audience for performance contracting. I'm very pleased to be with you today, and the thing I'd like to add here is I have been involved in a lot of different performance contracts over the years, Georgetown County, South Carolina, a number in North Carolina, including universities, and we just recently, as Ally Engineering, finished some of the engineering work for the town of Chapel Hill's performance contract they're doing with Piedmont Service Group. It wasn't a water project, but it did involve 2 of their pools. So anyway, that's all good. The way I'd like to get started is to tell you about a project that I worked on for the city of Kings Mountain in North Carolina. It's been about 10 years ago, but and it's a small city, and ESCOs you're going to find like big projects. They are big companies in general, and they like big projects. They have some overhead to cover, and most of the small cities end up having small projects. But what you realize is that the 40% of the energy in a city or so is used by the water utility for the water pumping and the wastewater treatment plants. And so it does offer some opportunity. So interestingly, in the city of Kings Mountain, they were originally approached by a water meter company who wanted to provide AMR water meters. And so they didn't have the funding, and the AMR water meter company decided they could go with a performance contract to provide that. And that is often done, and I believe we're going to hear about that from Corey here in a bit. But so the city first considered AMR. We were brought in as Siemens and met with the city manager and the mayor to discuss different challenges in the city. Because another thing you're going to find out is that ESCOs like to do a comprehensive look with the city. And it's an important issue. We found out here that meter reading was really not the big issue for them. What was the big issue, particularly, was their 40-year-old oversized water pumps and switchgear. And that was the biggest issue by far, and they didn't have any money in the capital improvement plan to solve the problem. You can see the picture of the water plant on the right hand, of the water utility offices, and they have huge storage in this town. It's one of the characteristics of a lot of towns in the South where they used to have textiles, and they used to provide lots of water for textile companies. Not so much anymore. More to hear about that in a minute. So the city also needed a new chiller system and control system for the city hall, and they have the typical needs that people have of reducing their operating costs. So what we did is we talked with the politicians essentially, and they decided to bring in the people with the intimate knowledge and let us talk with them. So once we talked with them, we agreed to do a feasibility study for performance contracting. The feasibility study involves collecting a lot of data, analyzing it, doing walkthroughs through the buildings, trying to find what could be done. So when I was walking through the wastewater treatment plant, through the water supply plant and talking to Junior, and you can see his pickup truck parked right there in front of the office. So Junior was there during the day operating the pumps, and he was providing water to the tank that I showed you in the previous slide. So in this small building in the bottom left-hand corner of this picture were three 400 horsepower pumps. And they were sitting there running during the daytime. And guess what? That's when Duke Energy charges the most for electricity. So it just immediately struck a chord in my mind that there was an opportunity to run those at night or off-peak. The next important discovery was at the wastewater treatment plant. They also needed upgrades and no money, and we've already mentioned the city hall, but they did want to provide additional air conditioning for it was a city building operated by the YMCA there in town. So those were important things. Okay, so we got through the feasibility study, we went to the city council, and after all the stakeholders were involved, having their input in terms of financing, what that needs to look like, in terms of the water utility, in terms of the general maintenance for the city. Everybody had a chance to plug in, and I would recommend that that's a very important thing to do early on before you get to an audit, because then you'll know what the project needs to look like in the end. Also, let me suggest to you that the audit is something that does take time. So often people are anxious to move forward with their project that they don't allow enough time. Engineering requires time. You really need to probably put in data loggers. You need to know what the operation has looked like over some period of time in order to do it well. So we did the audit, and certainly the city agreed to operate the water pumps off-peak. But Junior, as I mentioned earlier, he didn't really like that idea because he had a great job coming in at like 9 o'clock, leaving at 3 or 4, and now we're going to ask him to come in at night and operate these pumps and be on site. And that may seem strange to a lot of folks, but this city had 9 million gallons of storage capacity in their water system, and they only really use something less than 3 million gallons a day. So it provided for a great opportunity for them to pump the tank, shut off the pumps, and go home. So you may hear in Corey's slide or other people's about operational savings. This is one of the rare cases where the ESCO actually funded additional money to the city so that they could pay additional money for their staff to work at night. I thought that was a pretty interesting concept there. So what we did find out, there were enough savings here with not only the demand savings, but other things that we could do, more efficient pumps, that we more closely sized to the pumps to the load and future growth, that we were able to replace all the pumps, both in the supply plant and the booster plant, and to give them much more efficient and new operation. At the wastewater treatment plant, we changed the process slightly to provide fine bubble aeration equipment there, and it reduces the energy used by quite a bit in that case. We did look at inflow and infiltration in their waste system, because they were actually they were actually paying another entity to treat some of the wastewater, and when they got that infiltration, it increased the volume, and they had to pay more. But it turns out, if you can imagine how expensive that was, we did a lot of video testing and tried to find leaks, but it was too costly in the end for them to include that in the performance contracting. Certainly citywide lighting was included. Interesting story there. They had 4 traffic lights in town. Many of you may have that many or less. And at the time, LED traffic lights was a big deal, so we promoted that, but they suggested that their traffic lights were of a historical nature, and they did not really want to change them. Thought that was pretty interesting. Then one last thing about the audit before we could actually close the deal was the city looked at what we were doing, and they said, oh my goodness, we could install the lighting ourselves if you could provide the product. So a little bit more on that in a minute. So certainly we did the audit, and before we could go to contract, we had to discuss how to do the funding. Well, I developed this little graphic on the right-hand side of the page years ago, and it's helped me and others to understand how this process works. It's really, you have a present situation at the top and then a desired situation. And with performance contracting, you're able to use like a line item transfer in order to fund the project. In other words, you take money out of your utility budget and you put that same money back in another line item to fund the municipal lease to pay for the project. So eventually in North Carolina, the city council approved it, and then the state ended up having to approve it. So we got that done after a while, and then the construction began. And with any construction project, there's always a story, and there were several stories in this project. The first thing that happened was I was out walking my dog one morning early, and the project manager called me from the site and said, oh my goodness, the air conditioning unit's delivered with the wrong voltage. So boy, we're off to a great start. Anyway, we got new units and got finished with that. At the wastewater treatment plant, the engineer of record, whom we usually work with on a project like that, he passed away, and so with that happening and then the state not paying quick attention, we didn't really know how to expedite it that well. The process to get it approved took over a year. That was not a good thing. Then because of that, the wastewater treatment plant equipment was delivered, and it remained outside, and there was some rust and things like that that got inside these compressors, and that had to be overcome. But the worst thing was the operation produced too much noise. We really didn't know that until the end. So I'll share with you how we solved some of that in a minute. Of course, the pumps at the main water plant and the booster plants were installed without water delivery interruption. Can you imagine if you were an ESCO and you were to shut down the city water? That did not happen. The city staff and the lighting supplier struggled with getting exactly the right applications and delivery. The chiller change out went very well. We put a new SCADA system in for the water plant. It had some IT issues. It seemed like it took forever to get that fixed. And then the impact that it had on the city here additionally is that the project took 30 months to complete, or something like 30 months when it should have been 12. And that impacted the cash flow and cost the city money. So we were able to, as the ESCO, help them fund that. We actually paid them some money back to cover that excess cash flow that they had, and we paid back some some money for the to cover the sound. Now this picture, believe it or not, is from Google Earth, and it shows the wastewater treatment plant located right here. Look around there. There's nothing around. By the way, this is a blow-up of the blower units here and the fine bubble aeration that were put into one of the ponds. But look around here. There's not anything around, and when you drive out there, it's so far away, you just can't believe there will be a problem. But the sound generated in that blower unit actually reached, because these were up on a hill a little bit more, actually reached these homes. And our project manager went out there at night and took his sound meter, and he said, you know, if it were me, I wouldn't like it either. I think it was just a very small home in the background, but you know, they've been living in peace and quiet for years, as many of you do, I'm sure now. And so what happened was we had to build a sound enclosure around these blowers in order to get the sound to an acceptable level. It turned out right nice, but it did cost a lot of money. So I've got one more slide, and I want to wrap up here and share a few things with you in terms of what I'd recommend. Finally, the construction was completed, and as I mentioned, there were several problems that came up. However, there were no change orders to the city, and that's one of the values that performance contracting brings, is that because it's a cash flow issue, because it's a problem, you borrow exactly a certain amount of money, that is the amount of money the ESCO has available to do the project, and they know that going in. Plus, they're really the design build contractors, so it's their responsibility to find anything that could come up or could require cost and to include it in their project, so there's no change orders. Now, certainly if the city wanted to add something, you could do it. In the end, the ESCO corrected all the issues, and the savings have been achieved, and the city has been pleased with that. They would have never, they would still have, they would have now 50-year-old pumps, probably. So the last item here, again, that I'd like to suggest is that the budget was not directly affected. One of the things that performance contracting does, it can't take advantage of capital avoidance. In other words, in North Carolina it cannot, some other states it can, but where you might have money budgeted for some work to be done in the city, that really is a savings in some ways, but in North Carolina you can't take it into account, except that those capital funds that the city may have tried to budget for pumps, for instance, now can go to other priorities that the city has. So that those were the results, and I'm pleased to be able to share some of that with you. My name and phone number is at the bottom. If I can help anyone to get engaged in a performance contract with an ESCO or with someone else, I'd be happy to do so. Don't hesitate to call me. It does take a relationship and some expertise, some trusted relationships in order to have this process be successful. So with that, I'd like to turn this over now to Corey Cox and let him continue the webinar.
Frank, thanks very much. This is David Tucker. I'm just going to introduce Corey here real quick. And thanks very much for that last point you made, too, which is important to emphasize, where Frank was saying that if you're going to do a performance contract, it does involve building a longer-term relationship with someone, since that contract may last for 5, 10, 15 years. And so you do want to find someone you're comfortable working with. Mr. Corey Cox is the Public Utilities Director at the City of Pickens in the fine state of South Carolina, our neighboring state. It's been a pleasure getting to know Corey and talking with him in the last few months about their experiences, because they are a small drinking water system, local government system there in Pickens. And they have worked, as Corey will mention, with an ESCO, the Energy Systems Group. I also want to say before Corey starts talking that we can see from the attendee list that Mr. Philip Lowery is on the line with us here, who introduced us to Corey, and Philip works for ESG. And I want to say thank you to him, too, for his time and expertise in helping prepare us for this webinar. So, Corey, feel free to take it away now.
Well, David, thanks for that introduction. As I get started here, want to give you a little bit of an insight on who the City of Pickens is and how we operate, and also get a little bit of a shout out to ESG for making this project happen. You know, they came on board early on, and Philip as well really made this project a success. We're in the construction phase now, and I'm going to kind of talk through a few of the pieces leading up to that and where we are now, and then some of the performance guarantees and such. But just to get started, like you said, I'm the Public Utilities Director for the City of Pickens. And just a little bit about who we are. We're a small community just outside of Greenville, South Carolina in the upstate. About 5,000 water customers and about 2,200 sewer customers. Our sewer system kind of stops at the city limits, and our water system extends out into the county several miles. But we're just outside of Greenville. We do have a water treatment plant and a wastewater treatment plant. Water treatment plant's about a 4 MGD plant. We're currently doing about 2 million gallons a day, and our wastewater treatment plant's designed for a million gallons a day. And just kind of so you can kind of understand who we are, we have about a $3 million operating and capital budget per year that we have to work with, if that helps some of the other utilities kind of understand who we are. With the performance contract, David talked a little bit about the steps, and I'm going to kind of hone in a little bit on the preliminary audit piece. The first thing that we had to do was to set up an RFP and hire an ESCO, and it ended up being Energy Systems Group. The preliminary audit is kind of the second phase, then the investment grade audit that we've talked a little bit about today. Then you enter a contract phase and a construction phase where we are now, and then you review and evaluate. That's the M&V piece that David talked about, and ours is a 15-year contract with Energy Systems Group. But the preliminary audit phase is by far the most, I guess, fun. The most fun for the utility, for the engineers. It was more or less a roundtable discussion, looking at different aspects of our system, and kind of to parallel with what Frank said. Our project started out as a peak shaving project at our water plant. We were going to buy a generator, and we were going to install some new pumps, and it was about a $750,000 project to shave power at the water plant, and save a little power money and put it back towards some capital. And then as we sat around this table and looked at different aspects of the system, we started venturing into the distribution system, and we started venturing into the wastewater plant, and at some point we brought out our capital improvements plan, and Philip and myself and our city administrator sat around and looked at what was on our capital improvements plan, and kind of took a hard look at where the power savings were. Well, some of these things have a lot of power savings. Maybe we can capitalize here, capitalize there, a little bit of low-hanging fruit in some areas. And kind of as the project developed, we ended up getting completely away from the generator piece at the water plant and the peak shaving, which the operators were excited about, because similar to what Frank said, our operators were going to have to change their operating times, and they weren't happy about that. So they were excited that we moved away from the peak shaving. We saw enough power savings just by changing the pumps that we didn't need to venture into time of day rates and things like that. So the preliminary audit is really, for me as a utility, the most important piece. Got to look at a lot of different aspects of the system, the distribution system, the collection system, the water plant, and the wastewater plant. A little bit about our project, the actual things that we did. I got a couple slides that show it a few different ways, but we sitting in the preliminary audit phase, in the roundtable discussions, we started talking about meters and changing a few meters out. And we were going to do that internally, and then eventually we just looped it into the whole project, looked at a few different systems, ended up with a master meter drive-by system. We were looking at some fixed network stuff, and it really just didn't make sense for the city. The additional cost with the topography of our area, the drive-by was the correct fit for us. We moved from a touch read system to a drive-by system, and saw a lot of operational savings there. There's two pieces of a performance contract. There's operational savings and there's power, utility savings, and this was definitely an operational piece. We did end up installing some new pumps at a pump station, at a water pump station, and really got a SCADA system for our distribution system that also helped in operational settings. Less trips to tanks and lift stations checking things. We could all see it on the screen. The water plant, like I was saying earlier, morphed from a generator project to really a pump replacement project. A lot of our pumps were 40, 50, 60 years old, and so really started replacing pumps everywhere throughout the plant. New finished water pumps, 300 horsepower pumps. Ended up with VFDs on those that really ramped up the power savings. New source water pumps at our raw water creek pump and our lake source, chemical feed pumps, and then we did a SCADA overhaul at the water plant that kind of tied all that together, allowed us to go to some flow pacing and do a few different things there that were nice features that got looped into the project. And like I was saying earlier, these were all items that were on our capital improvements plan that were spread out over 5, 7, 10 years. And being that the performance contract focused on power and operational savings, we were able to kind of loop all those things together into one project, roll it up in a project and with a nice delivery. The wastewater plant, which we were not looking at all initially in the preliminary audit phase, we started kind of probing at the wastewater plant, where can we save some power, and there were some things that really jumped out at us. We were using jet pumps for mixing and aeration, and we ended up going with a large and fine bubble mixing system, and this actually ended up being one of the biggest power saving pieces of the project. So this is kind of a slide that ESG prepared for us. It kind of lets you see what we were seeing when we were going through the audit phases and we were decision-making piece. So if we take the first item here, the AMR system, if you notice the first column, utility savings, there's not really a whole lot of utility savings, no power savings. It's all operational, and that's related to meter readers and vehicles and things like that. If you take another example, the water pumps, all power savings. We wouldn't have any operational savings because we didn't do any time of day shift, and we didn't do anything different on the operation side. It was just simply new premium efficiency motors with VFDs, allowing us to save energy. So after the preliminary audit phase and the investment grade audit, you enter into the contract phase. For us, that ended up being a 4. Earlier, they had to absorb some cost in their project. ESG has had to absorb some cost in our project, and have been very willing to say, we took on the risk, and we're willing to compensate for that risk. So there's been a few hiccups, but all in all, it's been a very, very good project. And then the last piece of our contract, it ended up being a 15-year contract for the M&V phase, as David would say, on the measurement and verification, how much money we're going to save in power and operations over 15 years. So there's a 15-year contract there. So a little bit of how we paid for it. This is where David was talking about earlier. How do we pay for these things? We had to issue a revenue bond. It was the largest bond the city's ever issued, so that was eventful. Everybody was a little anxious. We did get a third-party financial advisor. ESG would provide numbers, and we thought those numbers were accurate, but just to kind of reassure ourselves and reassure council that we were being very looking at this at all angles. We got a third-party advisor to look at things and give us a third opinion. And then I would say, if you're going to venture into this, you need to get the bond attorneys in the process early. Sometimes they're very familiar, sometimes they're not. So getting them involved early is definitely a plus. I'm probably going to skip this slide. This kind of just shows a little bit about the finances of how we made the project work. We ended up with a debt coverage at the end, 1.72 to 1.82, which we feel is pretty good for us. We had to have a 1.2 minimum coverage for our current bonds. And then kind of some of the takeaways of what we learned, pros and cons. The first being, it's a very unique funding mechanism that allows you to loop a lot of projects together that's convenient for the cities. And then having one project manager was extremely nice. Whether it's a contract issue, a construction issue, or really any issue, I've got one point of contact to go to, and Phil and Tony Lassier is that for me with ESG, and it's been a very very good relationship that's been in our favor. So that's been very good. It is a design build format, so that usually is favored. A lot of people like design build formats, and I do. And then the nice piece is the performance contract has guarantees with it that if we don't see power savings, the ESCO basically reimburses you for what you said that they said we were going to see. So that's definitely a pro. One of the cons here, it's always hard to measure operational savings. There's a lot of operational savings in that meter reading piece, $275,000, and we're not going to fully realize that because I'm not necessarily firing that second meter reader. He gets relocated to another position within the city, so we still have benefits and we still have salaries for him. So we weighed all that in when we looked at this, and looked at it from the third-party angle as well. Took that into account to make sure the funds were going to be there. There is a little bit higher of a design, in the design build format and the performance guarantees. There's a little bit higher of an initial cost than traditional projects, but you're paying a premium for a turnkey, very user-friendly format in the design build with the performance guarantees. And a couple things that we learned, the banks, especially the small local banks, don't necessarily care how much money you're going to be saving. They really want to know, can you still pay the loan off? If you don't save any money, you're still going to be able to make the payments. The larger banks that do this on a more frequent basis are a little bit more willing to work with you on that. But the small banks, the local ones, they don't really care. They don't understand it, so you kind of end up at the larger banks to make the revenue bonds work the way you want to. Make sure you're conservative with your operational savings. Look hard at that. Are you really going to fire that person when the rubber meets the road? Are you really going to save that amount of money? And then the last piece of advice, and this kind of goes with any project, don't finance a project for longer than the useful life of the equipment. Sometimes you see this with USDA 40-year loans on a meter piece. Most likely you're going to replace some piece of a meter before 40 years. So try, if you can, not to finance for longer than the useful life of the equipment. And that's just kind of a good rule of thumb for any contract. But all in all, very, very good project for us. Learned a lot throughout the process, and would definitely do it again. It was a good fit for the city, and was a good project for us. So with that, I'm going to turn it back over to David, I believe, for some questions.
Thanks very much, Corey. I really do appreciate that. We're going to be taking your questions in just a minute here. And in the meantime, we have one or two quick questions to ask you. So my colleague Laura is going to launch this polling question on your screen in just a moment. We have a blog here at the Environmental Finance Center at UNC, and we see a lot of activity on it. We post to it every week with things about energy finance or water and wastewater finance. We hope that you'll sign up for it. It's free, and we just use your sign up for access to the blog. We don't, sell it to the Russians or anything like that. All right, and I think we can close that one now. Don't need to show that one on air, of course. And then for the next slide, there we go. We have an evaluation link that will be coming at the end. But in the meantime, we want to know if you're interested in receiving some free in-depth technical assistance for your small water systems. So again, to be eligible for this, you need to be 10,000 or fewer people served. You can answer yes, no, or would like more information. So on the energy front, for example, think of it this way. It could be things like we have an Excel-based tool we can use to help you to build your baseline of where you're starting from. If you want to get a grip on that before you do projects, we can help give you ideas about energy management projects to do. We can familiarize you more with the 7-step model developed by NYSERDA, the New York State Energy Research and Development Authority, that's been very helpful to us. So that's just a few ideas there. So let's close that one now. And so we had some great questions typed in by y'all while both Frank and Corey were speaking. And I'm going to direct this first one to Corey. Corey, there's a question about, did water loss control and evaluation of apparent or real losses enter into the distribution system portion of your project development there in Pickens? Does that make sense?
It does, and it definitely did. One of the things we were looking at when we do our audits every year is the amount of, like the question states, water loss and within the water audit. And I think we were at, gosh, I think it was like 39% prior to this project. And we, in the first few months, we quickly realized that we're gaining 10 or 15% back right away with the meters. So there's a lot of other areas that we can still save and still, improve on things, but it takes us, 10 or 15% back right away when you install new water meters is a huge plus, and it really puts us on the right track for improving our water loss percentages. But yes, it definitely came into effect in the discussions.
Super. I don't know if Glenn or Frank, you have anything to add on that point.
This is Glenn. I mean, the only thing that I will add is, of course, we have a separate section of this project looking at water loss, and there's a difference between apparent water loss, which is, inaccurate meters. You're not bringing in as much money because you're not charging the right volume of water. But obviously, if energy is one of the largest controllable costs, but you're controlling that cost to just pump water into the ground, it's not a very good operation. And so, if you're within the normal range of water loss, it's probably not a huge deal. But if you're one of those systems that is maybe 35, 40, 50, 60+% water loss or non-revenue water, that's probably something you would want to address first before going into these kind of heavy energy improvements.
Indeed. All right, well, we have another question here I'm going to address to my colleague Glenn about, do we have any business case studies for the ESCO or performance-based contracting model to illustrate bottom line financial position performance metrics?
Yes, so thank you for this question. And I would say we'll try to pull together and send out to you all some links to where you can find case studies on performance contracting, but they're not hard to find. If you even just go into Google and type in performance contracting case study, you'll probably find a good number of them. But the U.S. Department of Energy has a page on performance contracting that has a number of case studies that include to some extent this financial information that you're looking at. And we'll see if we can find some that really are good in-depth on the financial side and send them along. EPA also has a page with a few case studies. Those are of federal buildings that have been done. And then there's also a group which is the National Association of ESCOs, and that is another resource. And David has just pulled up on the screen for you, and this will be in the slide deck we send out, several links to useful websites, and many of these include case studies as well. So thank you very much for that question.
And I'll just add go ahead, Frank.
Yes, I would just like to quickly add one more, and it's on my slide, really, and I forgot to mention it. It's about the Energy Services Coalition, and that's a group of individuals that would, collectively, it's a nonprofit, try to help eliminate hurdles to performance contracting. And so, EnergyServicesCoalition.org would be a good site to look at.
Thanks so much, Frank. We have one more question that's come in here, which I'd like to address to all of the panelists, anyone who would like to speak to it, which is, I'm interested in getting some energy savings performance contracting going at my system. How do I get started?
So Corey, what was your first step in Pickens? How did you guys initially decide this was the right avenue to go?
Well, I guess we kind of had an idea of what we needed to do to begin with at the plant, and that led us into all the rest of the projects. I probably start with a local engineer. You know, there's some as a utility, you're going to have some idea of where you can have power savings, and either partner with a local engineer to help you develop an RFP, or to create your own to get an ESCO on board. And once you get the ESCO on board, then you'll really dig in and find all that savings that you really want. It's kind of hard to say exactly because it's going to be different with everybody. But if I had to do it again, I would take a local engineer and develop an RFP and go at that route. Does that make sense? I hope that answers the question.
Indeed. And David Tucker here, I'll add one point on that and then see if Frank wants to chime in as well. Depending on where you're located, it's a strong possibility that in your state, that your state energy office will have resources posted on their website that will be supportive, such as a template RFP that you can start from. I know for a fact you can find that on the State Energy Office websites for North Carolina and Colorado, for example. And Frank, do you have anything to add on this how do you get started question?
Well, I'd like to chime in just a bit. Certainly the State Energy Office is a good source. The Energy Services Coalition has templates for you. But really, I think you'll see that both at Kings Mountain and in Pickens, those organizations were able to get one of the ESCOs to come in and help them with some feasibility, and that was at no charge. I'm assuming in the case of Pickens, but it was at no charge in Kings Mountain. And this is a very viable way to do so. And just like if you were going to, buy a car or something, you'd drop by several dealers and maybe talk to somebody about what's available. I think you need to really do that, and one of the ESCOs is willing to do that for you, I'm sure.
Thanks, Frank.
And this is Glenn. Just the last point I want to add is, depending on your state, you may be required to put this out for bid through an RFA process, an RFP process. Other states, that's not the case. So do be mindful of state law in terms of if you want to do these contracts. Sometimes we find water systems have an existing relationship with one of the ESCOs, and they say, well, we just want you guys to do it. And I know at least in North Carolina and some other states where we've worked, that's not allowed. So just be very mindful of that as well.
David Tucker here again. I'll just add to that one more point before we wrap up for today. You'll see on that link slide that's on your screen in the middle, there's a link to the Oak Ridge National Labs, the ornl.gov one there. And it's a survey of relevant ESCO legislation around the country. I think that's a good resource too. Because you always want to have the most current information, I would still go directly to your relevant, government agencies. Also, along the lines of just kind of the 30,000-foot overview of this topic, yours truly did do a blog posting last month that is on the EFC's blog. You can see at the top of the slide there. I know some of you might want to get in touch with Frank or Corey or Glenn or myself after the webinar with more questions. So you'll see on your screen there our contact info. And don't worry if you can't jot this down fast enough right now, because we are going to be sending out to all of you a follow-on email with a link to the slide presentation and the video, as well as the survey link if you haven't already filled that out here in the last few minutes. I want to say thank you so much to all of you in the audience for tuning in with us today for this fourth and final energy management webinar in this series. Thank you very much to Mr. Corey Cox, Mr. Frank Shepard, Mr. Glenn Barnes, and also my colleague Laura Flagg up in Syracuse EFC for your help. I hope you all have a great afternoon, and we'll be seeing you out there. Thanks a lot. Bye-bye.